Hello everyone. Climate change has been a hot topic for the past few years. Seeing this, we decided to do a study on this global topic by analyzing what people are saying on Twitter about climate change. Our research is titled Unraveling Public Opinion on Climate Change, an English language Twitter analysis using LDA and advanced sentiment classification techniques. It was conducted in 2024 by Nicholas Irvin Suhendi and Marvel Martawijaya with guidance from Alexander Agung Santoso Gunawan and Jeffrey Junior Teja Sulaksana. Today, we will go over the introduction, methodology, results, discussion, and conclusion of our study. The Earth as we know it is changing. According to WHO, there has been an approximately 1.1 degrees Celsius increase in Earth's temperature since the 1800s. An accelerating sea level rise by approximately 3.6 millimeter per year, and projected annual deaths of 250,000 from 2030 until 2050. This study goes beyond basic sentiment analysis, diving deeper to uncover nuanced themes in climate change discourse. By identifying specific concerns, emotions, and topics, it provides a richer understanding of public opinion. These insights are invaluable for policymakers, enabling them to address public concerns more effectively and craft strategies that resonate with people's emotions and priorities. This study aims to analyze public sentiment on climate change using Twitter data, identify key themes driving climate change discussions via AI technique, explore how nuanced insights into public sentiment and themes can inform the development of more effective climate change policies and communication strategies. Here is the workflow we adhered to when conducting the study. First, we gathered 1,500 tweets containing the phrase climate change. Then we employed 3 data labelers and set the majority label for each tweet. The labeled data is then taken to be preprocessed. Next, we performed sentiment analysis, preprocessing, and modeling, implementing techniques such as number removal, synonym replacement, punctuation removal, and other text preprocessing techniques. For the models, we used Fader, Roberta, and Bertweet. Now, having trained and evaluated all the models, we select the results from the best performing model and group the documents based on their sentiment. The grouped documents are then used for topic modeling, where we implemented 2 models, namely LDA and BERT-TOPIC. The models are tasked with the generation of topics for each sentiment. We then select the top topics per sentiment based on highest coherence score. Finally, we generate a short description for each sentiment based on their top topics. Our study uses 1,500 English language tweets from the year 2024 that contain the phrase climate change and was gathered using the Tweet Harvest API. The command used to retrieve the data and columns retrieved can be seen on the screen. Processing the data for labeling, we removed all the columns except for the column full text. Here is a snippet of our data after the columns removal. To avoid deadlocks, we employed 3 data labelers who are tasked to label the data using 3 labels, which are positive, neutral, and negative. Next, we will go through the main text processing techniques used in this research. First, the removal of unnecessary elements, where URLs, retweet indicators, mentions, and emojis are systematically removed to reduce noise in our text data. Then, we have hashtag normalization, where hashtag symbols are removed while maintaining the keyword for better analysis. The keywords are kept because they usually provide context to the main idea of a tweet. Next, we normalize repeated characters and typos as well as tokenize and remove stop words to further reduce noise in our data. We also implemented synonym replacement and data augmentation for the minority class to balance the dataset and prevent bias. For modeling, we performed sentiment analysis and topic modeling using several models. This was done to test which model fits our data best. For sentiment analysis, we used Fader, Roberta, and Bertweet. For topic modeling, we used LDA and BERTOPIC. To evaluate the models, we used F1 score as the metric for sentiment analysis due to our data having some degree of imbalance. As for topic modeling, we used CV coherence involving NPMI as part of the calculation. The final part of our research involves theme analysis, which was done using BERTOPIC and LDA. The goal here is to identify optimal topics, calculate coherence scores, and extract keywords for each sentiment category. The model with the highest quality topics is selected for further analysis. Having selected the model, we now generate the keywords for each topic and summarize them into main themes using Claude AI. The results are then used to provide nuanced understanding of central themes and emotional tones in climate change discourse on Twitter.
Moving on, we're going to discuss our results. Let's start with the performance evaluation. The advanced score table shows that Bertwit performs best with a score of 0.84, followed by Roberta and Fader. In the coherence score analysis, the topic outperforms LDA across all sentiments, achieving higher scores with fewer topics. For example, in negative sentiment, where topic scores 0.78 with 4 topics, compared to LDA's 0.35 with 9 topics, highlighting its efficiency and coherence. These are the keywords and themes for neutral group. These are the keywords and themes for positive group. Last but not least, these are the keywords and themes for negative group. Here are some word clouds to validate our results. In the discussion, word topic outperform LDA in coherence scores for the negative and neutral sentiment groups, while both models showed lower performance for positive sentiment. Neutral sentiment dominated the dataset, emphasizing objective topics such as climate patterns, political coverage, and economic developments. Positive discussions were also focused, highlighting climate action, green energy, and conservation with optimistic language. Negative discussions, however, reflected distrust and skepticism, often addressing economic concerns and opposition to environmental policies with terms like hoax and scam. In conclusion, our study analyzed 2024 Twitter data using advanced NLP techniques, with per topic excelling in topic modeling and Bertut achieving the highest advanced score of 0.884. Neutral sentiment dominated, focusing on objective topics like climate matters and economics, while positive sentiment emphasized solutions and negative sentiment reflected skepticism and economic concerns. Key limitations included data imbalance in positive sentiment and limited contextual modeling. Future work should address these issues by using balanced dataset, advanced overfitting techniques, and hybrid models for deeper insights. Thank you all for your time and attention today. We hope this presentation has provided valuable insights into our study and its findings. If you have any question or would like to discuss further, we would be very happy to engage.